Hi grade 11s, and welcome back to more complex quadratic formula questions. So this is the second part of quadratic patterns. The first video was on just getting us used to the basic idea, and now we need to look at 3 examples of more difficult types of questions that they can ask. Don't forget to hit pause whenever you need to and make sure that you've got the notes down. So our heading, more complex quadratic formula questions. Example 1, if you're given the quadratic sequence. Now the moment I see the word quadratic sequence in any exam, alarm bells need to go off and I need to think constant second difference, because that's what makes a sequence quadratic. It's the only defining feature of a quadratic sequence, and so it's definitely going to be used in most questions. So they've given me the quadratic sequence. It was 3x and 11, and it says if the formula for the general term is, and they've given me the formula. Now they haven't given me much, but they've given me what a is. Now the moment I see that, I'm reminded that the constant second difference is equal to 2a. So if I actually know what a is here, I can find my second difference. So let's go and write down my sequence so far. My sequence is 3, then x, then 11. So I can find my first difference. Well, an expression for it is 3 minus x and 11 minus x. Now if this was a linear sequence, those differences would now be equal, because the difference of a linear sequence is constant. Now this isn't, so I'm going to continue. So my second difference is 11 minus x, subtract, and notice you must have the x minus 3 in brackets because you're subtracting the whole thing. So if I simplify this quickly, this is 11 minus x plus 3. So this is 14 minus 2x. Now what do I know about the second difference? I know the second difference has to equal 2a. And I know what a is because they gave it to me in the formula. So I know it must equal to 2 times 2, which is 4. So I land up getting negative 2x is negative 10, because 4 minus 14, and x is equal to negative 5. So just to kind of link that in our notes, the second difference was actually given to me because they told me what a is. So a really nice way of kind of testing that you know that the second difference is 2a. Now it says if it is given to you that b is negative 4 and c is 5, so what they've done here is they've given you the formula. The reason why they sometimes do this is if you can't find out what x is, then you can't find the formula and then you can't do this question. So to avoid that, they've given me the formula and they've said determine whether 970 is a term in the sequence. Okay, well, how would I know if something's a term in the sequence? A number is only a term in the sequence if its position, which is n, is a whole number. We chatted about this in the previous video, but if a term is in the sequence, its position has to be something that's possible. And the only possible positions you can have are whole number positions. So you can't have fraction positions, you can't have negative positions. And so if 970 lands up being in this sequence, it means that if I put in 970 as 2n, will I get out a whole number? Do I get a position that's possible? And so basically this lands up being a quadratic equation. So the hard part in this question was interpreting what you needed to do. Actually solving this is something which should be fairly easy for us. Now, I'm definitely going to be using the quadratic formula because I don't know what the factors of 965 are. So negative b plus minus the square root of b squared minus 4ac given to you on your formula sheet. So you don't have to show me the formula, you just have to show me the substitution. And then you don't have to show any working. You're welcome to use the calculator and then just write down the answers. So I got answers of 22,99, which is not possible because that's not a whole number, or n is equal to negative 20,99. Now both of those are not possible. If this was a term in the sequence, I would need a whole number, and so therefore 970 is not a term in the sequence. So a very important take-home message in this question is if something is given as a term, you have to be able to get a whole number for n. If it's not a term, you won't get a whole number. Right, let's move on to our next question. Now, this is a lovely question. This question says, a quadratic sequence, so the moment I see quadratic sequence, my mind should say constant second difference. And this question has said to me, it has a third term equal to 9. So I don't actually know the terms of the sequence, but if I just draw myself some lines, I know the third term is 9, but I don't know anything else. Now, this is the part that makes this a nice question. The first differences. So if I could work out these differences, these are called the first differences. Now, this question says, these first differences form another sequence. Now, this is a really important concept for us. Why would these differences here, why would they form their own sequence? Now, they would form their own sequence because if I went on and found a second difference, this second difference would be constant. And what that would mean is that it would be the first difference of this sequence of first differences. So if these numbers are a constant, it means the line before it has to be a linear sequence, because the first difference of a linear pattern is constant. So really importantly, the first differences of a quadratic pattern always form their own linear pattern. So first differences of a quadratic pattern form a linear sequence. Now, this is a concept that is used quite a lot, especially in matric. And so I'm just going to say this again and explain it again. I don't know this sequence at the moment, these first differences, but I do know that the difference between the first differences is constant. So those first differences must be linear. Now, in this particular question, they actually give me the formula for that linear sequence. And that linear sequence is 6n minus 4. So I can actually work out what those differences are, because the first term would be 6 times 1 minus 4, which is 2. So that first difference will be 2. What my second first difference would be is 6 times 2 minus 4, which is 8. So this is 8. Now that means I can actually work out what my constant is. My second difference must clearly be a constant of 6. Now that also makes sense if I look at the formula, because this was 6n. So I can actually fill in that this must be, I can keep on going now if I wanted to. This is 14, this is 20, etc. But basically the first differences are a linear sequence and the second difference is constant. Now, I haven't even looked at the question. This question said, can we determine the first two terms? And now we can, because something has to be added to 8 to get 9. So this must be 1. And then the first term, if I add 2, I must get to 1. So this must be negative 1. So my first term of my quadratic sequence is negative 1. And my second term of my quadratic sequence is 1. Don't get confused that 2 and 8 are the first and second term of the linear sequence. So what happens here is if I have a quadratic sequence, my first differences are always a linear sequence, and my second difference is constant. Right, so how do we use this concept even further? This question now says calculate the value of term number 44 minus term number 43 of the quadratic sequence. So what happens here is I have got terms in my quadratic sequence and then they carry on, and somewhere down the line I have term number 44 and I have term number 43, and I want to find out what's that difference. That's what I'm actually looking for there. Now so far I know that this is negative 1, this is 1, then my first difference is 2, this is 8, so this is 9. And I could keep on going. This is 14, so this is 23. And now I could try and keep on going until term number 44 and term number 43, but that would be a bit ridiculous. It also says without determining the value of these two terms in the question. So there should be a way for me to figure this out. Now, what is that way? This number here, this is T1 of the linear sequence. And what is it equal to? It equals to the second term of the quadratic minus the first term of the quadratic. So it equals to T2 of the quadratic minus T1 of the quadratic sequence. So can I not look at the similar pattern? So let me have a look at the next one. 8, if I just write myself a note here, this is T2 of the linear sequence. And what does it equal to? It equals T3 take away T2 of the quadratic. So it equals T3 take away 2 of my quadratic. And I could keep on going. So basically what I'm trying to figure out is, what does this mean? What term is this of the linear sequence? So if this one is T1 and T1 is actually T2 minus T1, it's those numbers that match. And T2 is actually T3 minus T2 of the quadratic. So if I'm trying to do T44 minus T43, this must be the 43rd term of the linear sequence, simply because the 43rd term of the linear sequence, those numbers match. So the 43rd term will actually be the 44th term minus the 43rd term of the quadratic. So this formula Tn equals 6n minus 4 predicts this line of first differences. I just had to figure out, am I looking for term number 44 of that linear pattern, or am I looking for term number 43? And it turns out I'm looking for term number 43. Now I only knew that because I went and looked at all the other differences to kind of see the pattern. So I worked that out and I get an answer of 254. So this difference here is 254 between the 43rd and the 44th pattern. Now that's a really difficult concept. So if it's something you aren't enjoying, do get in touch and I can help you with it. Right, on to the next one, determine a formula. This should be something that's now easy for us because we've practiced it. So it's -1, then 1, and then 9. So this was 2 and 8, and this was 6. And now the three numbers I actually need is this number, because my first step, step number 1, is that 2a will be equal to your second difference. So I know that a will be equal to 3. My second step is that this number there, the first differences, is 3a plus b. So 3a plus b will be equal to 2. And so 3 times 3 plus b equal to 2. B will be equal to -7. And my last step is that this first term is equal to a plus b plus c. So a plus b plus c has to equal -1. So 3 minus 7 plus c has to equal to -1. Sorry, I've run out of space. So I get c is equal to 3. Now just don't forget to answer the question, because the question said determine a formula. So this is 3n squared minus 7n plus 3. Now what's great is that you can just substitute in n as 1 and check that you get -1, and then substitute in n as 2 and check that you get 1. And then you'll know that you've got the right formula, which is quite nice. Okay, on to our last question. This is also a really nice and quite common question. This question says the sequence 5, -13x, -67 is a quadratic sequence. Now again, the moment you have a quadratic sequence, the only defining feature is a constant second difference. So let me go and look at what my sequence is so far. The question says calculate x. Now this is going to have to center around the fact that you have a constant second difference, because that's all I know about quadratic sequences. So this first difference is -13 minus 5 So I'm going to simplify that and write negative 18. This is going to be x minus 13, so x plus 13. And this will be negative 67 minus x. Now that's my first differences. If this is linear, those would all be equal. Now it's not linear, so I need to go and find my second difference. So it's x plus 13 minus 18, which is actually plus 18. And then it's minus 67 minus x minus, and just be careful, you have to subtract the whole of that difference. So if I neaten this up, it actually becomes minus x minus 13, which is negative 80. Sorry, let me erase that and write it more neatly. Negative 80 minus 2x. So now I have two different expressions. That's an expression for my second difference, and this is an expression. It's not simplified yet, but those two second differences must be equal because you have a constant second difference. And so I now know that x plus 13 plus 18, which I can simplify, must equal to minus 80 minus 2x. So that's x plus 31 must equal to minus 80 minus 2x. So 3x must be equal to minus 111. And if I divide by 3, I get negative 37 for x. Now what's wonderful is you can go put that negative 37 in and then just quickly work out your first differences, work out your second differences, and see if your second differences were actually constant. So that's great. Now it says hence or otherwise determine the nth term of the sequence. Now this is something we should be good at now. Now I do actually have an expression for that second difference. This is the second difference, negative 80 minus 2x, or I could use this x plus 31 to actually find my second difference. So instead of actually redoing everything, I could say 2a, which is my second difference, has to equal this x plus 31, which I've gotten from there because it's just the easiest thing to use. Now I know that a is minus 37, so minus 37 plus 31, so 2a is negative 6. So this means that a is negative 3. Now I could have actually written out the whole sequence and worked out my second difference, but it was a little bit quicker just to use what I've already found. Now what is my sequence so far? My sequence, if I scroll up, is 5, negative 13, and now negative 37. So that is negative 18, which I'd worked out, and I've now worked out that my second difference was negative 6. So I've used the negative 6 to find a. My next step is to use that. So my second step is to say, so 3a plus b will be equal to negative 18. So 3 times negative 3 plus b will be equal to negative 18. And so if I add 9, I'll get b's negative 9. And finally, I'm going to use the idea of the first term, which is the fact that a plus b plus c is going to have to equal 5. So negative 3 minus 9 plus c must be equal to 5. So if I add that to both sides, add the 3 and add the 9 to both sides, I think I get 17. So what is the nth term of my sequence? Tn is equal to negative 3n squared minus 9n plus 17. Now again, I'm quickly going to sub in n as 1 and I check if I get 5. Sub in n as 2 and check if I get minus 13, just so that I know that I'm right before I move on. So I checked both of those on my calculator and they did actually work out, which means I can carry on because I know I've got the right formula. So now this question says, which term is the first term to be less than minus 1002? Now the first thing to notice is they have not said that minus 1002 is actually a term in the sequence. I don't actually know. So I'm not necessarily expecting n to be a whole number, because they didn't say which term is equal to minus 1002. They said which term is less than. So far I know that my formula is minus 5n squared minus 9n plus 17. Now, I don't particularly want to do an inequality. We hate inequalities at the best of times. So I know it says less than minus 1002, But I'm going to say, well, when would it be equal to minus 1002? Then I'll worry about when it's going to be less than, simply because I don't like to solve inequalities. So if I can avoid them, I do. Now, I'm going to bring my 5 over this side, simply so that I can have a positive, just have it really. So if I'm minus 17, I'll get minus 1019 equals 0. Now again, I'm definitely going to use my quadratic formula here. So I'm going to say n equals negative b plus minus the square root of b squared minus 4ac all over 2a. Pick up my calculator, and I get n is equal to 13.40, or n is equal to negative 15.20. Now this isn't possible. There's no ways n can be negative. Now what does it mean by saying n is 13.4? What it means is that minus 1002 isn't an exact term in the sequence, which isn't unsurprising. They never said it was. Now they want to know which term is the first term less than that. So let me quickly write out the sequence for you. This sequence was 5, then negative 13, negative 37, negative 67. So as you can see, it's going further and further down. So eventually it'll get to some term, and then it'll get to a term which is less than. Because it's going down, it'll eventually get less than minus 1002. Now which term is that? Well, if 1002, negative 1002 was a term in the sequence, n would have been 13.4. So that means term number 13 would be slightly bigger than minus 1002, and term number 14 would have dipped below that. So when it says which term is the first term, it is the 14th term. Now most people just round off 13.4 to 13, and they don't realize that term number 13 would have been above minus 1002. So it's not that we're rounding off our answer, we're not. We're thinking to ourselves, which term would now be below that? So I actually have to round up to term number 14, because term number 13 wouldn't have gotten as low as minus 1002 yet. So a little bit of an interesting question. Notice I didn't use an inequality here at all, because I don't want to solve a quadratic inequality. So I prefer to do it as an equation, and then I think about when it will be less than, as opposed to using an inequality. Right, so those were more complicated ones. So I've chosen 3 questions from the textbook just to practice these exact ideas, and then hopefully we'll be feeling really confident with our quadratic patterns. Well done, keep going.